students, good morning. In this video I am going to explain how we can evaluate the determinant. So here, as we can see, it's a 3 by 3 matrix and this straight lines is the symbol of determinant. Determinant can be represented like this or like this, two straight lines and the matrix elements inside. So now I'll show how to calculate. See, determinant can be calculated along any row or any column. Okay, so I'll show 2-3 different ways of finding the determinant, and the answer will be same in every case. So let's most commonly we find a determinant along the first row. So we should also know that the position of the element is odd or even. If the position of the element is odd, in that case we have to put a negative sign before it, like 3, its position is first row first column, so 1 plus 1 is 2, even position. But when I look at -1, it is in first row second column, so first and second adds up to 3, so its position is odd, so it will have a negative sign while calculating. And -2 first row third column, so 1 plus 3 first third, 1 plus 3 4, so it is at even position, so the sign will be positive. Only for the odd position elements there will be a negative sign, which is the important thing to remember. So let's start calculating. So first I will write 3 and then eliminate row corresponding to 3 and column corresponding to 3, and we are left with only these 4 elements, right? And the same scenario will be for each case, for -1 and -2 as well. We will be left with 4 elements and we have to do the same thing for each case. So what we have to do, cross multiplication, this into this minus this into this, so 0 into 0 is 0, minus 5 into -1 is +5, and so it will be -5. Now -1 is at odd position, so here I will put that negative sign which I was talking about. So minus of -1 into, eliminate its row and its column, we are left with 4 elements, so it is 0, and this will be +3. Then -2, because it is -2, eliminate its row its column, we are left with 4 elements, 0 0, so 0. Now it is -15 plus 3 is -12. So we got the determinant of this matrix is -12. Now if I tell you that you can even calculate the determinant along this first column, the answer would be same. See how we calculate it. Or, so this is even position, so 3 times eliminate this row and this column, we are left with -5. Then this is second row first column, odd position, so put negative sign, and 0 into 0, 0 into anything is 0 only, right? So eliminate it, no need to write. So 3 times this is 1, 3 5s are 15, -15 plus 3, again we got -12. So similarly, keeping this thing in mind, that the position of the element is odd, we have to put this type of negative sign before calculating, and the result will be obtained. The result is same. So now let's solve the same thing for a new determinant case. Here I will be solving for along this column, third column. Okay, determinant. So its position is even only, first row third column even position, and -1 position is second row and third column odd position, and this is at the even position. So -2 times eliminate its row its column, 0 minus 6, then minus, because it is at odd position, then -1 the element as it is, into eliminate its row its column, this is -10 plus 3, -10 plus 3 is -7, and then 0 into anything is 0. So here 6 2s are 12, minus to minus plus, then minus into minus is plus, plus into minus is minus, so this is 7. 12 minus 7 is 5. So along the third column, when I calculated, I got 5. Now again, for your convenience, if I calculate along the first row, again I will get the answer 5. So we are free to choose any row or column, but generally every time we apply first row expansion only, we expand the determinant along the first row only. So let's do it. And most preferable is the row or column in which maximum zeros are there. That will be the most convenient way to find the determinant for any matrix. So here let's find. So twice of, eliminate this row this column, 0, and this will be -5. Then it is at odd position, so and the minus 1 element as it is. Element this row, this column 0, and this will be plus 3. Then minus 2, element this row, this column 0, minus 6. So minus 10, this will be plus 3, and this will be 12. So minus 10 plus 3 is minus 7, plus 12 is again 5. So I hope this method is clear to everyone, that irrespective of the row or column, the result of the determinant remains same, provided position of the element is odd, we have to put negative sign while expanding it. So this is how we calculate determinant for any matrix. I hope this is clear. Please tell me which video you would like to see next. I will be coming up with that video. So thank you and have a nice day.